just before the title, please, the title. Looking at an investigation into an improved school student attendance register. This is a case of Technical University of Mombasa. My supervisors are Dr. Mugala, Dr. Hadulo, and Dr. Musau. First, I wish to acknowledge the institution, Technical University of Mombasa. And then we move to the problem statement. The paper attendance register that we commonly use, is to be signed for every lecture a student attends, and this is very tedious. It's time wasting, and it's open for cheating. For an average size of 40 students, it could take up to about 15 minutes to sign the attendance register, and this cumulatively will take will waste a lot of hours in one semester for that one unit. Next. Here we see students. This is how students sign attendance in class. And you can see on the paper the student is signing, there is already one column that has been signed, and he is signing a new column. So you will already see that there are some lectures that somebody has already signed, which he did not attend, or they are probably the future. It cannot be verified whether the first column is the lecture that he is attending, or he is signing for a class that he should have attended before. Next. My objective is to develop an improved college students attendance register. That's the main objective. Specific objectives: to identify the functional requirements and user requirements, and to design the biometric attendance register for university students, to develop the biometric attendance register, and then to test the attendance register. That is my abstract. Because of time, I may not dwell so much on the literature, but that is my abstract. Again. Then the introduction. It is a common academic rule or requirement that in all institutions that a student must attend at least 75% of all lectures in a given course to qualify for end of semester exams. Also, calculating the percentage attendances for each student in each course using data from the conventional paper attendance registers can be very difficult, and it's also time wasting, time consuming, and it is prone to errors. Next. We first look at some biometrics technologies that have been researched. Aderonke has suggested and defined that biometrics is a measure of the human physiological and behavioral characteristics which provides reliable identification of an individual person. Those are the definitions first. Next, we look at the types. There are two groups. We have one, the physiological, and the behavioral. Those are two major groups of biometrics technologies. And just before, please. Physiological characteristics to include the hand geometry, fingerprint, facial, retina, iris, ear. Those are among the physiological characteristics of a human being. The behavioral characteristics or traits, these include dynamic signature, voice, the lip movement, and also keystroke dynamics. Next, so I have highlighted in very brief statements each of these biometrics. Maybe for interest of time, I can just look at one or two, then we move to the next stage. The hand geometry, we use a camera to capture an image of the hand with the help of a mirror to get also the edges. And the hand is unique for every individual. Next. The facial recognition, we also use a series of images from my camera or from a photograph. The goal is to analyze the unique shape, the pattern, and the positioning of the visual features. So the others, next. The others are the retina, next. The iris, next. The ear, dynamic signature, voice recognition, lip movement. Just before we go to the next, lip movement here, even as I talk, if I were to remove my face mask, the movement of my lip is unique. Professor here will not move the lips the way I move them. So that can be, that is something that we can use to identify individuals. Next. Keystroke, yes. So then we have fingerprint. This, I have decided to put it last because this is what I'm going to do. Fingerprint identification. This is a very common technique. And it's been used over time. We started with ink and paper. Now we are using sensors. Next. The main purpose here is actually to capture the print, the ridges, the curves, which are very unique for every individual. These are some of the people who have researched on fingerprint. Akinduikte has suggested a 3-tier architecture, which consists of enrollment, database, and authentication system. And many others have, many others have also suggested. This is the structure. We have the fingerprint reader, and the control unit, then the PC. So these are like 3-tier or 3-stage model. Next. Another model has been suggested by, this takes, just before the previous slide, please. This one was suggested by Mohammed. Next. And this one is suggested by Aderonke.